Welcome to Tatumasi. So at another video on electrostatics. So in this video we are going to do a previously asked JEE question. So please listen carefully. This JEE exams, NEET exams or common entrance tests, those exams are very easy. So we all are born with equal intelligence. So what makes us different is the dedication and the hard work. So please listen. This question it is asked in JEE Advanced 2014. So let us solve that question. So I will read the question. Charges Q, 2Q and 4Q are uniformly distributed in three dielectric solid spheres 1, 2 and 3 of radius r by 2, r and 2r respectively as shown in the figure. So I will tell you the first sphere, it is of radius r by 2. Second sphere is of radius r and the third sphere is of radius 2r. Okay. Once again, the first sphere, its radius is r by 2. Second sphere, the radius is r. The third sphere, the radius is 2r. And the charge given to the first sphere, it's q, and the second sphere it is 2q, and the third sphere it is 4q. Once again I am reading the question. Charges q, 2q and 4q are uniformly distributed in three dielectric solid spheres. Very important. It's not a conductor, it's a dielectric. Dielectric solid spheres 1, 2 and 3 of radius, first sphere radius r by 2, second sphere radius r and the third sphere the radius is 2r respectively as shown in the figure. The figure is given in the question. If the magnitude of the electric field at a point distance r from the spheres. So if magnitude of the electric field at point P, which is at a distance r from the center of the spheres 1, 2 and 3 respectively are E1, E2 and E3. I am explaining the second part of the question. If the magnitude of the electric field at the point P is at a distance r, the point P, this is the point P, which is at a distance r from the sphere, center of the sphere. So for the first sphere, the point P is outside because its radius is only r by 2. For the second sphere, the radius is r, the point P is on the surface because both the distances are equal. For the third sphere, the radius is 2r, the point P is inside the sphere because the point P is at a distance r from the center of the sphere. So the electric field due to the first sphere it is E1, due to the second sphere it is E2, this is E1, this is E2 and this is E3. So this is the question. Then they are asking which of the following statement is correct. Whether E1 greater than E2 greater than E3, the first statement. Second statement, E3 greater than E1 greater than E2. Third statement, E2 greater than E1 greater than E3. The fourth one, E3 greater than E2 greater than E1. This is the question. So did you understand the question? So this question is JEE Advanced 2014. So let me explain the question once again. So as I explained, charges Q, the first sphere, the charge given is Q. The second sphere, the charge given is 2Q. The third sphere, the charge given is 4Q. It's uniformly distributed in 3 dielectric solid spheres, 1, 2 and 3. The first sphere radius is r by 2. Second sphere the radius is r. The third sphere the radius is 2r. Once again, the first sphere the charge is q. Second sphere the charge is 2q. The third sphere the charge is 4q. First sphere the radius is r by 2. Second sphere the radius is r. Third sphere the radius is 2r. We are discussing about the intensity of electric field at a point P, which is at a distance capital R from these spheres. So the first sphere we are taking it as E1. Second sphere we are taking it as E2. The third sphere we are taking it as E3. For the first sphere, the point P will be outside the sphere because its radius is r by 2 and the point P is at a distance r from the capital R from the center of the sphere. For the second sphere, the point P, this is the point P, so which is on the surface. For the third sphere, the point P is inside the sphere. So this is the question. Then for the first sphere, the electric field is E1. The second sphere, the electric field is E2. And for the third sphere, the electric field is E3. Then they are telling which one is greater, whether E1 greater than E2 greater than E3 or E3 greater than E1. The choices it is given, E3 greater than E1 greater than E2, or the third choice it is E2 greater than E1 greater than E3, or the fourth choice it is E3 greater than E2 greater than E1. So now I think you understood the question, right? So before solving the question, I just want to talk about conductors, and here it is not a conductor. The important point, once again I am repeating, these 3 spheres are not conductors. They are dielectrics. So you know what is a conductor. So first point, the most important point in electrostatics. The first point is when charge is given to a conductor, I am talking about conductor, not about dielectric. When charge is given to a conductor, charge resides over the surface, but it behaves as if it is concentrated at the center. From there, in the last videos you can listen, we talk about electrostatic shielding, all these aspects. Those are all things are for the conductors. The vanishing of electric field inside a conductor is known as electrostatic shielding. So those things I already discussed in the previous videos. Electrostatic shielding. Even we are going to discuss in Gauss's theorem as well. But in the case of a dielectric, so what is a dielectric? That's my first question. So dielectrics are insulators, but they can transmit electric or magnetic fields, and they will get polarized in the presence of an electric field. So dielectrics are not conductors, very important. They are insulators, but they will get polarized. Their charge gets polarized in the presence of an electric field. So when you apply an electric field, the charge in the dielectric gets polarized towards one region. One region it will go, all the positive charges will move towards one region, and all the negative charges will move towards the opposite region. So that charges will create an electric field that will be opposite to the applied electric field. Once again I am repeating, dielectrics are insulators, not conductors. So they will get polarized. The charge in this dielectrics will get polarized when you apply an electric field. The third point is the polarization happens against the applied electric field. And the final point, the most important point, if the substance is made of a dielectric, the electric field inside the dielectric is not zero, but the electric field inside a conductor is zero. So from there only they will ask questions. It is better to stay inside a car rather than outside during lightning. So those are all applications of electrostatic shielding. So that we already discussed. So in this video, I am telling, in the case of a conductor, the electric field inside the conductor is zero. But in the case of a dielectric spherical shaped dielectric, the electric field inside is not zero, but the point is it will decrease as you go inside the dielectric conductor. Why it is decreasing? Because the electric field formed due to the dielectric polarization is against the applied electric field. That's why it decreases inside the dielectric. I think you got the point. Okay, so once again the important points I am telling, dielectrics are insulators. They will get polarized, electrically polarized when you apply an electric field. Inside a dielectric, the electric field is not zero, but it decreases as you go inside a dielectric sphere. Now we will come to our question. So I am talking, once again I am telling, the radius of the first sphere r by 2, the radius of the second sphere it is r, the radius of the third sphere it is 2r, charge given to the first sphere it is q, charge given to the second sphere it is 2q, charge given to the third sphere it is 4q. Electric field of the first sphere, in the question they are telling it is E1, second sphere E2 and the third sphere it is E3. P is at a distance capital R from the center of the spheres. So for the first sphere, the point P is outside. For the second sphere, the point P is on the surface. For the third sphere, the point P is inside the spherical conductor. Got it? So now intensity of electric field. I am coming to the intensity of electric field. That only that we have to find it out. That's the physical quantity here we have to use. For intensity of electric field, the most fundamental formulas, there are two formulas. One is F by Q, second one is 1 by 4 pi epsilon 0 into Q by R square. Since here it involves distance, so we will use the second formula. It is 1 by 4 pi epsilon 0 into Q by R square. For to simplify the calculations, I am taking this 1 by 4 pi epsilon 0 as K. So our formula becomes KQ by R square. Clear? So E is equal to 1 by 4 pi epsilon 0 Q by R square. This derivation we have already done in the previous videos, so that you can refer. So E is equal to 1 by 4 pi epsilon 0 into Q by R square. So I have taken it as 1 KQ by R square. So that's the general equation we are using here. E is equal to KQ by R square. So let me talk about the first sphere. For the first sphere, the intensity of electric field E1, we can directly use this equation. It is K into Q by R square at a distance P. So it would be KQ by R square. So the first sphere intensity of electric field E1 is equal to no difference. Charge is Q and the point P. We won't take the radius. Here the point P is at a distance R. So we are talking about the intensity of electric field at P only. So it is KQ by R square. That is E1. The second sphere, it is E2. E2 it is again KQ by R square, but here Q is 2Q. So K into 2Q divided by the distance, it is fine, it is R. So we have written E2 is equal to K into 2Q by R square. So the first equation, E1 is equal to KQ by R square. In the second case, E2, small difference, it's very simple. These questions, if you analyze, if you spend some time, these JEE questions are very easy. You have to understand the concepts. Then you can do any type of problem. So that's the way we are explaining. So once you understand the concepts, you can do different types of problems, whether it is JEE advanced or all, whether it is NEET exam, all type of questions you can do it. So first E1 KQ by R square, it is simple. E2 K into 2Q by R square. Here the charge becomes 2Q and the distance it is same. P is at a distance R square only. So E2 also I have calculated. But now I have to tell you, when you come to the third sphere, the point P is inside the sphere, inside the dielectric sphere. There is the problem. Since the point P is inside the sphere, the charge is enclosed by the sphere containing the point P. So that is another sphere. So it would be a sphere of radius capital R. It is not for Q. You are getting my point? For the third sphere, the point P is inside the sphere. So the charge enclosed by the sphere of radius R is not for Q. All the first sphere and the second sphere, the charges enclosed by the sphere which contains the point P, it's Q and 2Q, it's correct. But here it is not for Q. So you have to calculate that amount of charge. How much charge will be there inside the sphere of radius R, inside this dielectric, its radius is 2R. For that, we will use the surface charge density. Sorry, not surface charge density, oleum charge density, because it is a sphere, it is having oleum. So here we will use the concept oleum charge density. There are three quantities. One is linear charge density, next one is surface charge density if it is a plain sheet. If it is a solid shape, we use oleum charge density. Here it is a solid shape, so it's a sphere, so we will use oleum charge density. So you know the formula for oleum charge density. Oleum charge density is equal to charge by volume, right? Here the charge, it is for Q. So rho 3 for the third sphere, rho 3 is equal to charge is 4Q. It's very easy. 4Q by oleum. What is the oleum of this sphere? So oleum of the sphere, it is 4 by 3 pi 2R cube. 2R the whole cube. You have to understand, we are calculating the oleum charge density of this dielectric, not the inside sphere. That is very important. Did you understand that? Here you are not substituting R, the inside dielectric sphere. No. It is, we are calculating the oleum charge density of this entire dielectric. So, rho 3 is equal to 4Q divided by 4 by 3 pi into 2R the whole cube. Because the volume charge density we are defining is for the entire dielectric sphere. Okay. So it is 4Q by 4 by 3 pi into 2R the whole cube. So that we got it. Then if this is the volume charge density, what is the charge enclosed by the inside dielectric? It would be volume charge density into the volume of the inside sphere. You are getting it? So what is the charge? And so you have the formula volume charge density rho is equal to Q by V. Then Q is equal to rho into V. You are getting it? Rho is equal to Q by V. So Q is equal to rho into V. So the charge enclosed by the inside sphere is equal to this volume charge density into volume of the inside sphere. It is not outside. Into volume of the inside sphere. So it is equal to 4Q by 4 by 3 pi. 2R the whole cube is 8R cube into 4 by 3 pi R cube. So you the 4 by 3 pi, 4 by 3 pi, R cube, everything is cancelled, and you will get 4, this thing cancelled, 4 by 3 pi, 4 by 3 pi cancelled, R cube cancelled. Finally you will get this one, 4 and 8 get cancelled. This is, so you will get 4Q by 8. The remaining things got cancelled, and you will be getting 4Q by 8, that is Q by 2. You understood? So the equation is 4Q by 4 by 3 pi into 2R the whole cube, that is 4Q by 4 by 3 pi 8R cube into 4 by 3 pi R cube, that is, you will get it as 4Q by 8, that is equal to Q by 2. So the charge enclosed by the inside sphere, that is the dielectric sphere which contains the point P, it is only Q by 2, not 4Q. You are getting it? So we got the charge it as Q by 2. Then we can calculate the E3. E3 is equal to K into Q by 2, that is, we use again the equation intensity of electric field E is equal to 1 by 4 pi epsilon 0 into Q by R square, that is KQ by R square. 1 by 4 pi epsilon 0 we have taken it as K. So K into, instead of Q we will substitute Q by 2 divided by distance is R square. So it is KQ by 2 R square. So comparing all these equations, the first equation, it is E1 is equal to KQ by R square, E2 is equal to K into 2Q by R square, or 2KQ by R square, and E3 is equal to KQ by 2R square. So if you see, the biggest one here is the first 2KQ by R square. After that E1, E2 is the bigger one. E2 is equal to 2KQ by R square. E1 is half of that, that is KQ by R square. Again E3 is KQ by 2R square. Again half of E1, KQ by 2R square. So we can tell E2 greater than E1 greater than E3. That is the third choice, C. C is the answer. E2 greater than E1 greater than E3, because E2 is 2KQ by R square, E1 is KQ by R square, again E3 is KQ by 2R square, again half of E1, E3. So we can get the result E2 greater than E1 greater than E3. So the third one, the third choice, C is the answer. So you understood this. So again I am summarizing some of the points you can remember here is when you talk about a dielectric is a substance. It's an insulator, but it gets the charges are polarized when an electric field. Charges in the dielectric is polarized when an electric field is applied. So its behavior is different from conductors. The electric field inside a conductor, spherical conductor, or conductor is zero, but it is in the case of dielectric, it's not zero, it decreases as you go inside. Example for dielectric is mica, glass, these substances are dielectrics. So this is the question which is asked in 2014 for JEE Advanced. So I think you understood it. So these questions, it's very easy. You can easily solve. Once you get the concepts, you can easily solve these JEE questions. So after solving these questions, you apply these concepts, these formulas, to solve all other types of questions. We will come up with new, lot of JEE questions, previously asked JEE questions and solutions in the coming videos. Thanks for watching.